Sorry about that, because actually our yp is equal to exponential of x times integral of x times exponential of minus 2x dx. Our integral is equal to this term, so you just plug it in. Okay, and then you just distribute the term of exponential of x in there, you would get minus x, right? Exponential of minus x. Okay, that's it. Now the next topic is to do partial fraction integration. To do partial fraction integration, saying that if our PD again is equal to this term, and then you know that when you write down the differential equation, it is in the term of y is equal to 1 over PD fx. So that means you have 1 over d minus r1 times d minus r2 times until d minus rn and time with your fx. In order to doing the successive integration, is saying that what if I use the partial fraction technique to make the 1 over PD term in this form? And we know that a1, a2 until an are constant, right? We know that if we do partial fraction, you would get a1, a2 until an as a constant. So in this case, because you have the summation term of each PD, so you can do distribute the fx into each term. So you would get from this, you put the definition of 1 over c minus afx to each term. So you do integral for n time, but not successively. Okay, but not successively. Let's take a look at this example. Just the same example as the previous one, but instead of using successive integration, I'm going to do the partial fraction integration. Again, if they are asking you to find yp only, then do yp only. But if they ask you to find the solution of that differential equation, you've got to check whether it is a non-homogeneous. If it is, then so your final solution is composed with yp and yp. Okay. Now, to find yp by using the partial fraction integration, we've got to write out our differential equation in the terms of the operator. So we got which is exactly the same as the previous example, right? Now, instead of doing the integration right away, so we are going to use a partial fraction to separate these terms. So we would get a1 b minus 1 plus a2 c plus 1. To find a1, how do we find a1? a1 is equal to limits of c go to 1. And then you plug the value is equal to 1 there, you would get a1 is equal to 1 over 2. Again for a2, d go to what? Minus 1. And then you plug the value of d in there, so you would get a2 equal to minus 1 over 2. This is what we learned before, right? So you know what to do. So our yp is equal to 1 over 2 d minus 1 minus 1 over 2 d plus 1 and the whole thing times exponential of minus x. So we do distribution, we would get now you put the definition of what? The 1 over d minus a there. Okay. Each of them. Now, 1 over b minus 1 times exponential of minus x, this term. You put this definition there, what do you get? Now, our a is equal to 1, so you would get exponential of x integral exponential of minus x times exponential of minus x dx. And the other one, our a is equal to minus 1. So you would get exponential of minus x times integral of exponential of x. Our fx is exponential of minus x dx. Now, this 2 equal to exponential of minus 2x. Inside here is equal to 1. To do integral of this one, what do we get? Minus 1 over 2 times exponential of minus 2x. And to do integral of this one, what do we get? X. So we would get, which is equal to Does that look pretty much the same as the previous example? Yes, it is. But you're just using different techniques. The first one, you do successive integration. If you figure it out, you would know that you have to do by part integration. But this one, when instead of doing successive integration, to do the partial fraction integration, you would see that you don't need to do partial fraction integration. So the term of integration is much easier, but again, with this technique, you got to know how to do the partial fraction.